Hello everyone, welcome to today's lecture. In our today's lecture we are going to start with our chapter number 4, which is a data pre-processing. So today's real-world database are susceptible to noise, missing and inconsistent data due to the typically huge size and their likely origin results. So how can the data be pre-processed in order to help improve the quality of the data and consequently of the mining results? How can the data be pre-processed so as to improve the efficiency and as of mining process? So for that we'll learn the chapter number 4. So let's start. In this chapter we'll cover this concept, like first is a why to pre-process data, what is the need of data pre-processing. Next we'll learn data cleaning techniques like missing value, noisy data, data integration and transformation. Second is data reduction. In data reduction we'll learn data cube aggregation, dimensionality reduction, data compression, numericity reduction. At last, data mining primitives, languages and system architecture, and discretization and concept hierarchy is covered in this chapter. So let's start with the first concept. So before we start, let's understand what is a data pre-processing. Data pre-processing is a data mining technique that involves transforming raw data into an understandable format. Real-world data is often incomplete, inconsistent, and are lacking in a certain behaviors or trends, and is likely to contain many errors. So, data pre-processing is a proven method for resolving such issues. When we talk about data, we usually think of some large data sets with huge numbers of rows and columns. While that is likely scenario, it is not now always the case. Data could be in so many different forms, structured tables, image, audio files, video, etc. So data can be in any format, and a machine don't understand the free text, image or video data as it is. They understand only ones and zeros. So it is probably won't be good enough if we put on a slideshow of all our images and expect our algorithm or our model will catch that data directly from that image. So that never possible. So in any data mining process, data pre-processing is that step in which the data get transformed or encoded to bring it to such a state that now the machine can easily parse it. So that is why the data pre-processing is required. The next topic is why data pre-processing. So data in the real world is dirty, or data is incomplete, noisy or the inconsistent. Incomplete means lacking attribute values, lacking certain attributes of interest, or contain only aggregate data. It means the first figure shown in figure, the table contains some values, but on the table some values are empty, like this is star. It means the value is empty or the value is missing. This question mark, this dash. So this shows that the data is incomplete. It contains some missing values. So that is called the incomplete data. Next is a noisy or containing errors or the outliers. Noisy means in figure you can see that there is a two attributes and one class name. So in the attribute 1 and attribute 2, so here in attribute 1 it shows the time. Yes, so here equal is not the relevant attribute value. Also here the question mark is not the relevant attribute value. Yes, so that type of data is called the noisy data. And last one is inconsistent data. Inconsistent data means it contains discrepancies in codes or names. So it's shown in figure. We can see that here region is north. Now next is the region is WST, region is east. Now the same east region is shown with the E. The south region is written as STH. So that is not the consistent data format. If we talking about consistent, it means the format or the data is same for all. So here if we write an east, then for all the regions the name will be east. So that is why this is called the inconsistent data. So in the real world, these are main three attributes, that the data is incomplete, noisy, and the inconsistent. So a data have a quality if they satisfy the requirements of the intended use. There are many factors compromising a data quality, including accuracy, completeness, consistency, timelineess, believability, and interpretability. So imagine that you are a manager at one electronic company, and you have a charge with analysis the company's data with respect to your branch sales. So you immediately set out the performance of this. So you immediately set out to perform this task. You carefully inspect the company's database and data warehouse, and identifying selecting the attributes or the dimensions like item, price, unit sold. Yes, the important attributes you will select and select that to be included in your analysis. But you notice that several of the attributes for various tuples have no record value. For your analysis, you would like to include the information as to whether each item is purchased was advertised as on the shelf, yet you discover that this information has not to be recorded. Furthermore, users of your database system have reported errors, unusual values, and inconsistency in data recorded for some transactions. So in other words, the data you wish to analyze by data mining techniques are incomplete or containing only incomplete, inaccurate, or noisy. So that is called the real world data. Yes, if you want to analyze some task, if you want to do some data mining process on data, so you notice that data that is collected from multiple sources are not on the required format. It contains so many errors, it contains so many missing values, the data is too inconsistent. So that is why we cannot perform our data mining task without the data pre-processing. So that is why the data pre-processing is introduced. So before the data pre-processing, almost 70% of your time is goes on preparing your data set. So while with the help of data pre-processing technique, you can easily pre-process your data and perform your task easily. So if data is inconsistent, noisy, or the incomplete, then no quality of data. So that is why no quality mining results. So quality decision must be based on the quality data, and data warehouse needs a consistent integration of quality data. Without the quality data, we cannot reach to the knowledge or consistent knowledge or the relevant knowledge. So that is why we are performing the data pre-processing task. So some of the major tasks in the data pre-processing are data cleaning, data integration, data transformation, data reduction, and data discretization. So these are the tasks that we have to follow to pre-process our data. So let's understand one scenario that you want to perform a data mining task on some data, on the sales data. So first thing you retrieve the data from multiple data sources. Yes, so now you have a data. The first thing you have to do on that data is data pre-processing task. You have to apply some data pre-processing task to make that data more relevant. So the task of the data pre-processing that you are applying on that data set is a data cleaning, data integration, data transformation, data reduction, and data discretization. So by using that task, we can create one consistent data set. So these are the complete scenario that suppose you are collecting the data is dirty data. Now you apply the data cleaning, so you will get the clean data. Now then on the clean data you apply data integration and you get a complete data set. Now you apply a data transformation and you will get some more relevant data, and on that data you will apply data reduction. So after that stage, the data you will get is the more relevant or consistent data set, and you can use the data for further processing. So let's start with the first data mining task. In our today's lecture, we'll only learn the first data mining task, which is a data cleaning. So what is a data cleaning? So in the real world, data tends to be incomplete, noisy and inconsistent. Data cleaning routines attempts to fill in the missing values, smooth out the noise while identifying outliers and correct the inconsistencies in the data. So in the data cleaning, we'll learn some basic methods of data cleaning. So a data cleaning task, mainly a three major task has been done, which is a filling in the missing values, identifying outliers, and smooth out noisy data and correct the inconsistent data. So let's start with the first task, which is the fill in the missing value. Data is not always available. For example, many tuples have no recorded values for several attributes such as customers' income in SaaS data. So it is very much usual to have a missing values in your data set. It may have happened during a data collection or maybe due to some data validation rule, but regardless, missing value must be taken into consideration. So as shown in figure, you can see that this is a table of one data set, and it contains many attributes, but it has some empty values. Yes, so this empty value is called the missing data. And if you want to work with some data mining algorithm, then you have to fill that missing value. If you are using the data with the missing value, then it may give some inconsistent result, or it may give some unreliable result, because some important it may possible that some important values may not be used. So that is why it is very important to fill the missing value. Missing value data may be occur due to some equipment malfunction. Suppose if you are retrieving data from some equipments, yes, so it may possible that some due to some errors some of the data values will be missed. Inconsistent with other recorded data and thus deleted. Data not entered due to a misunderstanding. Certain data may not be considered important at a time of the entry, and not register history or changes of the data. So imagine that you need to analyze an electronic company's sales and customers data. You note that many tuples have no recorded value for several attributes such as customer income. How can you go about filling the missing values for these attributes, or such as customers income? So that may be possible due to this reason that I have described. So we have to recover that missing values. So how can you go about filling in the missing values for this attribute? So let's understand this. Let's understand how we can handle the missing data. So first is ignore the tuple. It means usually done when class label is missing. This method is not very effective unless the tuple contains several attributes with missing value. It's especially poor when percentage of missing value per attribute varies considerable. By ignoring the tuple, we do not make use of remaining attributes values in a tuple. Such data could have been useful of the task at hand. So it may possible that if we ignore the tuples, complete tuples, then some attribute who has some values, so that value also be that value also has been gone. So it may possible that due to the missing of that values, we will reach to the incorrect results. So that is the first way, which is ignore the tuple. Second is fill the missing value manually. So in general, this approach is time consuming and may not be feasible given a large data set with many missing values. So this is a very tedious task. If you have a data set of only 100 rows, then you can easily do this manually. But if imagine that you have one data set who has a 1000 attributes or 1000 columns and 32,000 rows. So in that data set, manually filling that missing value is a very tedious task, or it is not a feasible task. So the third option is use a global constant to fill in the missing value, like unknown or null. Yes. So replace all the missing attribute values by same constant, such as label like unknown or infinity. If missing values are replaced by say unknown, then the mining program may mistakenly think that they form an interesting concept, since they all have values in common and that of unknown. Hence, although this method is simple, it is not a foolproof. Yes, suppose you will write a unknown at each and every missing. You will fill unknown to every field where value is not assigned. So it may possible that it creates some different class, like it create a different class, or it determining algorithm understand unknown as some different context, unknown in different context. So it may lead to the inconsistent result. So this is also not a foolproof. Next is a user attribute mean to fill the missing value. So for example, suppose that data distribution regarding the income of an electronics customer in symmetric and data mean income is 56,000 rupees. So use this value to replace the missing value for income. Like you will consider the mean of all the values, and you will fill that value with that value. Next is a user attribute mean for all samples belonging to the same class to fill in the missing value. So this is a smarter way. Suppose if classifying customers according to the credit risk, we may replace the missing value with the mean income value for customer in the same credit risk category as that of the given tuple. So this is a very better way for filling the missing value. So in the data which is in the same category, use the mean value everywhere where the data on the same category. So that is the another method for filling the missing value. So use the most probable value to fill in the missing value. So inference based such as Bayesian formula or the decision tree is also used for handling the missing data. So that is how we can handle the missing value. I will show you one example that how we can fill the missing value. So for that I will open a Jupyter notebook, and I will show you one database which has a missing value. So suppose there is one database whose name is a property data. Yes, so it contains many columns and rows. Yes, there is one process ID, number, name. So it contains many data values. Here you can see that in the PID column, one field is missing. On the number column, two values is missing. Some value has a empty value, or the NA value, or this type of NA value, Yes, dash dash values all are called the missing values. Man is also the missing value. So we have to fill the data values with a defined technique that I already said. So we'll practically see that how we can fill that missing value. So let's open. I already coded this, so I will show you how we can do this. For that I used a library like pandas, numpy and matplotlib. First I read a CSV file of that dataset. So for that I have to import the file. Next I read the okay. I read that CSV file that I show you, and now I show you the complete data set. Here as I said that in the PID one missing value that is shown here, in the number two missing value that is shown here. Yes, so this is the data set which shows the missing value. Now we have to define which are the missing values. Suppose NA is also a missing value, normal NA is also a missing value, dash dash is also a missing value. Yes, so we'll define a missing value, and now we'll read the CSV file and we'll give the missing value here. That will say that these are the missing value in the CSV file. And now we'll count number of missing values in each column. So it is said that in PID there is one missing value, in number column 2 missing value, in name column 0 missing value. Yes, now as I said that there are multiple ways to handle the missing value. First, ignore the tuple. So in that we'll use this data set as it is. For that we'll use this data set as it is. Yes, this data set as it is. Second way is fill the missing value manually. Suppose it means that we open that file and will manually fill the missing value like with some numbers. Yes, so this is not feasible for large data set and also very time consuming. Okay, so the next is use a global constant to fill the missing value. So for that okay, now there is a 2 missing value in the st_num column. Yes, this is the first and this is a second. To fill this missing value with the global constant, means with the constant value, we'll use this function like df, which is a data set. In this we read the CSV file. So this is a database variable. So df of st_num dot fill na with 125. So it fills the null value with 125 constant value. So as shown here that this third value and this second value is filled with the constant value 125. We can see here in the complete data set. Yes, this is filled with the 125 and this is also filled with the 125. We can also do it with the PID. So we have to just replace the column name here, which is a PID. Now run this code. So in the PID there is a one missing value which is filled with the 125 constant. So this is how we can fill the missing value with the global constant. So suppose if there is a database of the students and the address attribute is missing for some student, as it does not make the sense in filling up this value, rather a global constant can be used. Yes, so each and every student has a different address, so we cannot use this way in that type of case. The next is use the attribute mean for all samples belonging to the same class. Yes, we can also use the attribute mean to fill the missing value. Yes, for that we'll use a mean or the median to fill the missing value. So here I use a median, and if you want to use a mean, then we can use a mean here. Okay, and run this code. So it fills num underscore bedrooms missing value with the mean value of that column. So we will see that num underscore bedroom has a 1, 2 and 3 missing value. So that missing value is filled up with the mean value. Yes. So this is how we can fill the missing value by mean or the median. So this is how we can fill the missing value while we are working with the real database. So I will show you how we can find the mean value. In our practical, it has a built-in function, but if I want to manually done that task, then suppose this is a database and it has a missing value, like in column A 2 and 3 is a missing, and in column C 1 and 3 is a missing value, and we can fill it by the means. So the equation of the mean is sum of the terms divided by number of terms. So if I want to fill the missing value of column A, then mean become 2 plus 10 plus 10 plus 10 divided by, there is a 4 there are 4 values, so divide by 4. So 32 divided by 4 equals to 8. So 8 is a median, 8 is a mean. So we can fill the missing value with the mean. So here second and third missing value is filled with the value 8. Same as in the C, if I want to fill this missing value with the mean, then so as per the equation, 2 plus 10 plus 10 plus 10 equals to 32 divided by 4, it is also 8. So that is why we can fill this missing value with the 8. So this is how we can handle the missing value. From next lecture we will learn the other data pre-processing techniques. Thank you so much for listening. Have a great day.